and the cooks started fighting in the restaurant as soon as Abby was leaving.
Okay, so here we go. We're going to pick up on number 16. So, and I hit record. So 16 is a word problem. It's kind of strange, but it's easy. But let's just make sure you can do it. Okay, so this says that a bus fare, okay, in a city is $1.25. Now, I know we don't really have things like this, so it's kind of confusing what that means, but that means every time you get on the bus, that's what you pay, okay? So every time you want to ride the bus, you pay that. So if X is how many times you ride the bus, that's how much you're going to pay total for your bus rides. Now, people who use the bus have the option of purchasing a monthly discount pass for $15. With the pass, each fare is only 75 cents. So what that means is if you pay $15 up front, then every time you ride the bus, it's only 75 cents if you show them your pass, okay? So you got to determine, is it worth it or not? So they want to know the number of times in a month the bus must be used. So the total monthly cost without the pass, which is this, is the same as the total monthly cost with the pass, okay? So this is without, you're just gonna write the number that they give you times X. With the pass is gonna be the pass plus how much it costs to ride the bus each time, okay? So this is gonna be how you set this up, all right? And I can't really remember, it could be a bus or a train, but it's one of those two. So it's either it's a train or a bus, and this is what you're gonna set up. That's the hard part. And then all you do is solve for X, okay? It's just a normal little equation. Everybody okay setting this up? Good, okay. Then we just subtract our 0.75x. We come up with 0.50x equals 15. We divide by 0.50 and we get a nice little number. And there you go. Okay. Okay. Sound good? All right. Any questions on 16? So that one's not bad. Don't freak out over it. Good? I'm going to move it. Moving. Okay. All right. Let's look at 18. 18 is just a really simple graph the equation. Say that. Oh, no, we don't need 17. Don't need 17. Not one of ours. Okay. So on the final, you know, you're not actually graphing. You're going to have 4 choices, A, B, C, D, and you just pick the one that looks right. That's it. Okay. Well, I don't know about you, but I think slope intercept form is the easiest way to find this. If you would rather do intercepts, you can, but I'm going to put it into y equals mx plus b because I think that's the easiest. Okay, so I'm just going to leave y where it is, and I'm going to subtract 4x from each side, and I'm going to end up subtracting 6. I guess I just could have added 6y, but whatever. Okay, so I'm going to end up with negative 6y equals negative 4x minus 6. Okay, or I guess you could have just added 6y, but oh well. Okay, now I'm going to divide by negative 6. And I get y equals a positive 2/3 x plus 1. Okay. Everybody okay just putting it in that form? No matter how you did it, you should end up with that. Okay, this tells me I have a slope of 2/3 and it's positive. And it tells me I have a y-intercept of 1. Okay, so if my slope is 2/3, once I'm on the y-intercept, what am I going to do? I'm going to go up 2 and I'm going to go right 3. What if this were negative 2/3? What would I do? Close, down 2, right 3. Okay, so we're still going right no matter what. Right, right, right. But if it's positive, we go upright. If it's negative, we go down right. Okay, is everybody all right with that? You may want to write that down just in case I can't remember. to right, up to right 3. Close whatever you're watching because you're always 5 minutes behind us because you're watching your show. Okay, you're always, okay, you're going up to right 3. If it's negative, you go down to right 3. You're always going right. Thank you. Okay. All right, here we go. So my y-intercept is going to be 1. Everybody got that? You do that first. Okay. And then I'm going to go up to right 3. And there's my line. Now, let me warn you that this was a beautiful little y-intercept of 1. I'm 99.9% sure on your final, your y-intercept is going to be something really crappy like 7/8 or something ridiculous, right? So if you're confused about it, put it in the calculator so that you can figure out what it is. You know, like 7/8, it's going to show you point, I don't know, 9 something maybe. And then you kind of know where it is on here. You will only have one choice with the correct y-intercept. Just one choice with the correct y-intercept. That's it. So even if you're confused about the slope, there's only going to be one of them that has the right y-intercept. So you really don't have to get too nitpicky with it. Okay. Is everybody okay with that?
So we always see the 9, and then we go like up to.
Good.
So I got it wrong.
All right. There's no 19. There's no 20. There's no 21. Okay. Is this good? Okay. All right. Let's look at 22. 22 is tricky. And let's talk about why. It shouldn't be, but it is. Okay. This says identify the intervals on which the function is increasing, decreasing, and constant. Okay, so it's multiple choice. Okay, yeah, it's multiple choice. So I'm going to have 3 things I have to look for, right? 3 little intervals. Now I'm pretty sure on the final, yours doesn't have anything constant. I think it's more like a, just a V, you know, like an absolute value or maybe a parabola, but there's nothing constant, but we're going to practice it. All right. When you are identifying these intervals, you're looking for X values only, and it is parentheses only. So if you see any choices with hard brackets, cross them out. Don't even read them, right? Parentheses only. Okay, here we go. X values though, here's where it gets tricky. This is what it's going to look like, but you're going to have to remember this is really going on forever, right? Okay, so I'm starting over here at negative infinity and I'm moving to the right. So what I notice is if I trace my graph, I start my pencil here, what is happening from here to here? Am I increasing, decreasing, or constant? Increasing. So that means this is a little increasing interval. Good. Okay, so let's name him. This is an increasing interval. So X values only. Where am I starting? Negative infinity. And where am I stopping? Looks like -3. Good. Remember, parentheses only. Okay, good. Now I put my pencil back on the graph. What am I doing in this portion? I'm constant. Okay, I'm going to finish him, make him little interval. Okay, where am I constant then? -3 to 3. Perfect. Okay, what's so tricky about this? It's a 3. You don't have your glasses on. Okay, so let's look at the next interval. That's the one that tricks people. Hey, Andrea. So that's the one that tricks people. Okay, so let's think about this. Put my pencil here and I'm going decreasing, right? Everybody knows I'm decreasing. Okay, I think we can all agree I start at 3. Everybody agree with that? Okay, here's the difference in the right and the wrong answer. This is the tricky part. If this were the range, I'm going toward negative infinity, but it's X values only. So Where is this going to end up x value wise? Positive infinity. And that's the right answer. Okay. That bothers people because it's heading down and they want to say, but it's going down. It's going to negative infinity. You're right. But it's moving outward and it's an x value only. So it's positive infinity. Does that make sense? Okay. All right, good. All right. Okay, let's go 23 and 24. Andrea, this is the same review packet we had from Tuesday, honey, but if you need more, there's more back there. Oh, you got one. Okay. All right, here we go. So 23, okay, for the given functions, find the composition. Okay, that's this. Remember, this is the only thing in the English or math language that you do not read from left to right. Which direction do we read this? Right to left. This means we're going to take g of x and put it where? F. Right on into F. So I'm going to seal up G because it's going on a trip, right? Seal him up. And he's going to go right on over here and be put into where X is. So I'm going to still have my 4, but instead of having an X, it's going to be multiplied by the 7x plus 4. And then I still have a plus 11. Everybody okay with that? Remember that little guy? Put him right on in there. Now we just got to clean him up. So I'm going to distribute. I get 28x minus 16 plus 11. That's 28x minus 5. And that's my answer. Okay. All right. Everybody good on that one? Okay. All right. Let's look at 24. Okay. 24 is a nice little quadratic. All right. Well, whenever you get a quadratic and it tells you to solve, my advice to you is the first thing you want to do is look at your answer choices. If every answer choice is a nice little number, they probably factored it. If you have an answer choice with a root or an I, guess what they had to do to solve it? Quadratic formula. So you're going to have one quadratic you have to solve that I feel like we already did, but maybe that's my imagination. Maybe it's coming up. That had really crappy answers and we had to solve it. Maybe it's coming up. It's coming up. So sorry. So when you look at this one, you're going to check your answer choices. His answer choices are going to be really nice little numbers. So we're just going to factor him. Okay. He's going to have nice little choices. Nice choices. Okay. All right. So he's a monic. I'm going to throw in X's. Okay, good. So I need factors of negative 50 that add to negative 5. So I already heard 10 and 5, easy enough. Now here's the thing you got to remember. In order to get a negative 50, somebody's got to be positive and somebody's got to be negative. Negative 10, positive 5, excellent. And that's because we want a negative. So that's what goes right in. We want a negative in the middle, so we give the bigger number the negative. Okay, this gives us the positive 10 and the negative 5, and those are your answers. They're going to appear in solution sets like this. So this would be the choice that you want. Okay, you'll look inside the little squiggles. In the little packet, that's how they'll have it. Yeah, just because they'll put it in order, smaller to bigger. Yeah. All right, are we good? We're going to skip 25. And he was, right? We put in a minus 10, good question, and a positive 5. Then when we set them equal to 0, they'll switch. Yeah. Good call, because one of your choices will be positive 5, negative 10. They'll put both. Okay. All right, 26 and 27. Okay, 26 has a lot going on. Yeah. Okay. So it wants us to write an equation for a line perpendicular to this line. All right, well, let's just stop right there for a minute. Okay, perpendicular to this line means that I need to find his slope. Can I tell the slope right now from that line? No, the only way you can tell a slope is when it's in this form. So I have no idea what his slope is right now. I got to do some work. Then when I find his slope, what am I going to do to it to make it perpendicular? Opposite reciprocal. I'm going to change the sign and flip it. Okay. I'm going to change sign and I'm going to flip. You would. Good. Good. So if it's a 5, you're going to make it 1/5 and negative. Okay. So let's do that first and then we'll worry about the rest of this. So I'm going to take this line and I'm going to turn it into a y equals. So I'm going to add 5x to both sides. Okay. So I'm going to get 7y equals 5x minus 2. Is everybody okay with that? I just added the 5x. Okay, I'm not done. I'm going to get y equals 5/7 x minus 2/7. Okay, this is this line. That's what that is. Okay, so what is his slope? 5/7. What is the perpendicular slope that I want to use? -7/5. See how we did that? So you're going to have a lot of work on this one little problem. You're going to have to solve him for his slopes, then flip and change the sign. Now we have the slope we want. Okay, let's keep going. It wants our line to pass through this point. Okay, so this is x1, y1. And here's our slope. All right, now it then wants us to put our final answer in slope intercept form. It's like, good gracious, instead of doing this, maybe we could have 5 other questions because this is making you do everything. Okay, can I immediately take my point and my slope and put it into slope intercept form? No. What form am I going to have to start off in? Point slope. Yeah. So you're going to have to start in the y minus y1 equals m times x minus x1. So we haven't had to memorize a formula yet, but now we do. Make sure that you know slope intercept and make sure that you know point slope, because even though it's not going to ask you for point slope, you're going to have to use it. Okay, here we go. So I'm going to have y minus 3 equals my perpendicular slope, x minus 4. Okay, is everybody okay so far on that? All right, are we done? No. We got to put it into this form. We got to solve for y. So we're going to distribute. We get -7/5 x plus 28/5. Now I got 28/5 because I multiplied the top. -7 times -4, and I got plus 28/5. That's where that came from. Okay, now I need to add 3 to both sides. You can do that right in your calculator. Okay, I don't have my little calculator out here, but remember, all I have is the big guy. But remember, you can do 28/5. Remember, you can do that little fraction button you guys have on there, right? And then I can add 3. And then I can turn this back into a fraction. And I get 43. On the big guy, I did math, frac, and enter. Okay. So I'm going to end up with y equals -7/5 x plus 43/5. Now, if you're not comfortable with that, let's go old school. How do I add 28/5 and 3? I'm going to add, I need to turn 3 into something over 5, right? So 3/1 into something over 5, it would be 15/5. Everybody remember how to make an equivalent fraction? And then if I add 15/5, that's what gives me the 43/5. So I knew it was 3/1. I needed something over 5. So I multiplied top and bottom by 5 to get it. And then I just added them together, if you like that better. Yeah. Okay, sound like a plan? Okay, any questions on that? That was a long one. All right, well, here's an easy one. Okay, so this example kind of stinks because let's just look at my tick marks. Look at the tick marks on here. It tells you this one's 20, so we don't have tick marks of 1. What do we think each tick mark is going to be? Yeah, they're actually going to be 4. I know that's crazy, but look, 1, 2, 3, 4, 5 gives you 20. So 20 divided by 5 means they're each 4. So this one's kind of stinky. Yours will have tick marks of 1. So you don't have to worry about it. Yours is not going to be wonky like this. And you will have nice little grid marks. So my girls that do this and get diagonal on me, right? You don't have to worry about it. You can be as diagonal as you want to be, okay? Because you're going to have little grid marks, okay? All right, but for now, try to keep it straight and you're going to have wonky grid marks or tick marks. Okay, so this is a positive there. Okay, so here we go. We want f of 16. That's what this means. What is that telling you and what is that asking for? This is telling you x equals 16. What is y? That's what it's telling you. F of 16 means f of x. So 16 is x. It's asking you what is y. So I go to my graph and I find where on my graph is x equals 16. Well, it's this little dot right here, right? This is x equals 16. So I'm going to go straight across. And again, yours is going to have nice little lines, so you don't have to worry about it. And what's my answer going to be? What's y? Hey, okay. It just wants the coordinates of this point. It gives you the x coordinate. It wants the y coordinate. All right. Okay, is that good? All right, Maria, are you okay on that? Okay, everybody good? All right. Okay, we're gonna skip 28. We're gonna go to 29. Hey, this looks like test 4. I think this is it for test 4. I think this is the last question. I forgot this one was even on there, but they're kind of mixed up. Okay, so it's going to give you this formula. You don't have to worry about the other formula. Oh, yes, absolutely. The only, yeah, you'll have these. These will be the only formulas you have. Yeah. Okay, so we know we're going to need this one anyway because it says continuously. It may give you both formulas, guys. I'm not sure. It may give you this one and this one. And so if it does, make sure you know you're using PERT because your question is going to be about continuously. Okay. All right. So what is this 5,000 number? Hey, that was weird. Okay, but it's right. All right. So that was P. That's our initial amount, our principal. What is this 5.6%? There's our R, but I can't write 5.6. What am I going to write? Okay, there were about 3 of you on the test that would have told me now I'm being 0.56. Thank you, Alexis. Okay, now I'm doing it, but 0.056. Make sure that you put that in your calculator. A couple of you messed up because you didn't have that extra 0. All right, what is 3 going to be? T. All right, are we going to panic because we don't have a number for E? No. E's in the calculator. It is a number. Okay, so A equals 5,000 times E times 0.056 times 3. Okay. All right, I'm going to need somebody to help me kind of baby step through this. So first thing I'm going to do is find my exponent. So what is 0.056 times 3? 0.168. Thank you, Shalondra. Okay, perfect. Now I'm going to do e to the 0.168 first in my calculator times the 5,000. And then I do have an answer for that. See if you come up with 5914.68. Okay, good. Okay. Because it's money. All right, everybody okay with that one? Okay. All right. Okay, we're going to skip 30 and we're looking at 31. Okay. 31 really confuses students, and I'll admit it's a terrible problem, but it's easy. It's just that it's like, what in the heck is it asking you for? Okay, let's think way back to parabolas. All right, so it says the cost C in millions of dollars for a company to manufacture X thousand automobiles is given by this. All right, we don't need to know any of that. All we need is the equation. Right? So if you don't want to talk about that other stuff, you don't have to talk about it. You got your equation. Find the number of automobiles that must be produced to minimize the cost. What this is asking you for is H, which is the X coordinate of the vertex. That's what it's asking you for. Good gracious, how do you know that? Well, it's a quadratic, so this is a parabola. It's opening up because 3 is positive, and it's wanting to minimize the cost. It's asking for the minimum point. That's how I know that. It's in math words, badly written math words, asking you for the minimum point. Okay, that's how I know, which is going to be the vertex. And because up here it told us X is automobiles, and this asks for the number of automobiles, that's how I know what this is. This is going to be your exact problem though, different numbers, but exactly worded problem. So when you get to the problem about automobiles, find your X coordinate for your vertex. That's it, okay? X coordinate of the vertex. So anybody remember how to find the X coordinate of the vertex? Opposite of B over 2A. Good for you. We got another formula to memorize here. Make a note where you're going to need that formula, right? If you forget that formula and you have the big boy calculator, you can graph it and find the vertex, but otherwise remember him. So that's 3 formulas now, right? Point slope, slope intercept, and this dude, okay? All right, so here we go. What is my B according to this? It's negative 60. I want negative B or opposite B. So what's my numerator? Just a 60 over 2. And what's my A? 3. 60 over 6. It's 10. Now, your choice is not going to say 10. I don't want to alarm you. It's going to say 10. And then remember, X is in thousands of automobiles. So it's going to say in words 10,000. That's going to be your choice. Okay. So that program is, that problem, huh? Yeah, that's it. It's super easy. It's weird. So I don't want you to be confused about it. Oh, that's the overthinking queen right there. That problem. Yeah. Okay, we are skipping along till 37. Everybody okay on this guy? Okay, 37. All right. So solve the equation. It's a quadratic, but look at your answer choices. Now, the last quadratic, I told you were going to have really nice choices, so we knew to factor. This guy, look at your choices. He's going to have ugly choices. He's going to have eyes in his choices. When you see eyes in your choices, what are you going to do? Quadratic formula. You're going to have to remember this. Let's see if we can remember him. So you can sing your little song, or you had a negative boy and he couldn't decide if he wanted to go to the radical party, but he was a square and he didn't go. And he missed out on 4 amazing chicks. And the whole thing was over when? 2 a.m. Okay, so now we're up to 4 formulas. 2 for your lines, the x coordinate, and the quadratic. Okay, here we go. My A is going to be what for this problem? 1. What's my B? And what's my C? 5. Okay, we're just plugging right on in here. All right, so negative B is -4, plus or minus. I'm going to square B, so that's 16, minus 4 times 1 times 5, all over 2 times 1. Okay. All right, we're going to clean it up. I still have -4 plus or minus. Let's see what's going on in this radical. All right, 16 minus, what's 4 times 1 times 5? Yeah, okay. So 16 minus 20, what's under my radical? -4. Good, and a 2 in the bottom. Okay, am I going to jump the gun and start reducing? Good. Okay, -4 plus or minus over 2. Okay, what's the square root of -4? 2i. The minute you see a negative under your radical, immediately put an I. Get rid of it. Then the square root of 4 is 2. Now we have ourselves a triangle. And I'm going to divide everybody by 2. And I get -2 plus or minus 1i, or just I. Do I have a denominator anymore? No. And there's my answer. Okay, so watch your choices. One of your quadratics you're going to factor, and one of your quadratics you're going to do the formula with an I, and you're going to need a triangle in the end. All right, we're skipping and we're skipping over to 41. Oh, I lied. We got another log. Princess Priscilla. I don't know why I do that. I think it's like Maricela, Priscilla. It's like there's a lot of like sounds that are similar in this row. It gets me. Okay. All right. Is 37 good? Okay. All right. 41. Okay. All right. Here we go. Solve the equation. Reject any value not in the domain. That means if it makes your domain negative, you have to get rid of it. But guess what? It'll be fine. Okay, here we go. So here's our problem. All right, it sure would be great if you could have log equals log, because I got a log over here, but here I have 2 logs. Anybody remember how to take 2 logs and make 1 log if they're subtracted? We'll divide their arguments. Okay, because they have the same base. So let's see if we remember how to do this. We're going to write log base 3. Keep your bases the same. Then they're subtracted, which means we have a division. The top is the first argument. The bottom is the second argument. And then look at there. That's nice. Okay, that's the key to this problem. Everybody okay with that? Okay, now we get to get rid of those and we don't have to deal with any logs anymore. We're just a good old fractional equation. Okay, now we do have to solve this. So you know I like to keep my stuff together, so I'll throw that in the bottom. Okay, so we're going to multiply both sides by what? X minus 3. That's my LCD. This is going to cancel, and on my right, on the left, what am I going to end up with? 5 plus X. On the right, I'm going to have 9 times that packet. Is everybody okay with that? Okay, so I'm gonna distribute my 9. Okay, I'm gonna get 9x minus 27. Okay, and then you just solve this any way you want. I'm gonna subtract x because I like my x term to be positive. And I'm gonna add 27. Okay, I'm gonna get 32 equals 8x, and I divide both sides by 8. I know I did that a little fast, but I just didn't want to do it too long. Everybody okay with that guy? You may have solved them a little differently than me, but you should end up with 4. You're good. Okay. All right, 42. Oh, so what it mentions domain. What it wants you to do is take this 4 and put it back in and make sure that the argument stays positive, but yours will. So I tried to write the question. That's it. Nope. All you need is x equals 4. Good. I wrote this like this because that's what your final exam question says. I want you to get used to it, but you can ignore that part. Yours is going to be fine. Good. Okay. All right. 42. What is it wanting us to do for 42? It says find f of 3. Yeah. This means plug in 3 for x and give it the answer. You guys are good at that. Okay. So I'm not going to spend too much time on that, but you just throw in the 3. Make sure you're okay finding the answer. I came up with a -5. Okay. Is that okay? Okay. All right. Okay. 5 more. All right. So this is how yours is going to be worded. And we want to make sure we can write it and we don't get confused because a radical is a little difficult. Okay. So write an equation for a function that fits this description. So this is your original. You're going to do stuff to it. You're going to take this little guy here. Okay. You're going to shift it 5 units left. Okay. So if I want to go left 5 units, am I good? Going to the left means +5. Okay. And that's where I was going to ask, where do you put that +5? Do you put it all the way out on the end or do you put it inside the radical? How do we know it goes in the radical? Because that's where x is. It's on x, right? It's on x. Okay. What if it said to go to the right? -5. Okay. So if you need to write that down, +5 is the left, -5 is the right, but either way, put them inside the radical. You're going to have a radical. Okay. 7 units down. Is that plus or minus? Minus. Where is that going to go? There you go. What if it was 7 units up? +7. Okay, good. So they're going to have all possible combinations of weird stuff happening. This is what you want. Okay. All right, 44. Find the inverse of the one-to-one function. I get a lot of questions going, I don't know what a one-to-one function is. You don't have to. One-to-one means it has an inverse. They're just telling you it's possible to find an inverse, that the inverse exists. Find the inverse. That's it. Okay. First step, we're going to replace f of x with y. Remember that? Sure. Okay. All right. Second step, we're going to switch the x and the y. Switch x and y. That's our second step. So I'm going to have an x equals a cubed root of y minus 5. Third step, solve for y. That's it. Okay, so let's think about this. How am I going to solve for y? He's under a cubed root. Good. I'm going to cube both sides to get that cube off. So I'm going to cube both sides. That's going to give me an x cubed on the left. And then on the right, everything pops off and I just get y minus 5. And now I'm just solving for 5. So I'm going to, solving for y. So I'm going to add 5 to both sides. And there we go. Now yours is going to put it into inverse function notation. So yours is not going to have a y any longer. It's going to have this little dude. Okay, you don't have to do that. Just make sure you're looking for the stuff on the other side. But that's what yours is going to be. Okay, so turn it f of x into a y, switch x and y, solve for the new y, and you're good. None, because it's a final. But I'll throw a little something there in the final grade for you. Yeah, okay. No, just a little. Miss Holcomb loves you. Okay. Okay. I know. Makes me sad. I'll be there. Yeah. Okay, here we go. Give the domain and range of the function. All right, well, it sure would be helpful if we knew what the heck this function was. What's the shape of this function? Parabola. Yay, Jolene. Parabola. Okay, so this is a parabola. We got a square. Am I opening up or down? Up. How do I know I'm opening up? Because this is positive out front. So this is what I got going on. That's what I got going on. Okay. So this is what I'm doing. What is the domain of every parabola in the whole wide world? Yeah, whether it's opening up or down, that's your domain. Good. Now yours is opening up. Okay, but that's what it is. All right. Now for the range, the secret for the range is you really need to know the vertex so that you can know the range. Now the vertex is very easy to find for this guy. Let me just put him in standard form for you. If you remember, this is what your standard form for the vertex is. Yeah, I mean, it wouldn't hurt. Yeah, if you remember him, I would. So put that down as one of your remembered. Okay, so my H is the opposite sign of what you see in here. And my K is exactly what you see. So what would be the vertex of this parabola? Good, 4, 4. Okay, it would be 4, 4. What if this were x plus 4 in here? What would my vertex be? Negative 4, 4. Okay, so it really helps if you can remember this formula to get the vertex. So let's think about that. If this is my y right here, okay, and I want the range, then I'm starting at 4, right? And where am I going? Infinity. Okay, it's going to be a hard bracket because you are including that number. You are touching that number. I know everything we've had has been a parenthesis, but this is going to be the only hard bracket you have. Only hard bracket you have. You might want to just make a note of that so you remember him. Okay. Okay, sound good? Oh, another task 4. Apparently they're just sprinkled throughout. Okay. All right, 46. Here we go. Solve the equation. Okay, so if we only have one log and we want to solve, we're going to do the circle thingy. This is the circle thingy. So what are we going to start with? 36. We raise it to the 1/2. And what does that equal? Equals x. Now, if you want to just put this in your calculator because you don't remember what it means, you can. But what does 1/2 mean as an exponent? Square root. So what's my answer? Done. But if you want to put this right in like this, because you don't want to have to remember anything else, you can do that. Your calculator will tell you it's 6. Just make sure you do this. You do 36 parenthesis 1 divided by 2, close parenthesis, if you're going to do it that way in your calculator. You know, last one. I can't believe we did it. I even showed my feet twice and we still did it. Okay, here we go. 47. Okay, oldie, first week of class, back in January. This is an intermediate algebra problem. Yeah, we're finding a common denominator. Solve the equation. Okay, so you know me, I like to seal everybody off. Don't leave anybody behind. All right, we have an equal sign, so we want to find our LCD. And you know, the right side doesn't even have a denominator. If you want to put him over 1, you can. You don't have to. Okay, so what is my common denominator? Good. 4 and an x minus 5. It's just both of those denominators multiplied together. Okay, now since I have an equal sign, I'm going to multiply the top of every term by that, the top. So I'm going to multiply the top of everybody by that denominator. Okay, that's the secret. Remember, I can do that because I have an equal sign. And then all the bottoms are going to cancel. So for this first term, the 4s are going to cancel. And I'm going to have 4x plus 7 times x minus 5. Now, if you have them in a different order, that's fine, as long as you know they're multiplied together. Minus. Okay, the x minus 5 cancels for that next guy, and I'm going to have 2x times 4. Now, if you went ahead and wrote 8x, that's great. I'm going to do that in the next step. Equals, I don't have anybody to cancel with on the other side. So 4 times x minus 5. But the important part is we no longer have any denominators. Sorry. Oh, because I'm multiplying by the top and I don't have anything in the bottom to cancel. The bottom, yeah, he's weird looking because you know don't see the bottom there. Say that. Oh, okay, thank you. Oh, because this and this, that's our LCD. We just multiplied both. So whatever your two denominators are, make that your LCD. Okay. All right. Anything else? Good. Okay. We're going to FOIL. I have 4x squared minus 20x plus 7x minus 35 minus 8x. A lot of distributing and combining like terms, but it's not hard. Oh, right here. Oh, because there was an x here. Mm-hmm. Okay, and then I'm going to have 4x squared minus 20x. Oh my goodness, things are just canceling like crazy. All right, here we go. Okay, let's go ahead. Before I do anything else, I'm going to combine this guy over here. If you see stuff, you could go ahead and cancel it a different way, you do it. You sure? Okay. Ask away if you have something that's bothering you. Okay, so over here I have 3 terms. Nope, I have 3 terms right here that I'm going to be combining, right? So I have negative 20x plus 7x. That's going to be negative 13x. Minus 8x is going to be negative 21x. And then I still have minus 35. Everybody see that, how I combined those 3? Okay, so this was negative 13x. And then when I subtracted 8x, I got negative 21x. I just put all 3 together. Okay, when I start moving terms around, if I subtract 4x squared, what's going to happen to the 4x squared? They're going to cancel. How beautiful is that? Yours is going to cancel too. Okay, now I'm going to add 21x to both sides because I still have to solve for x, and he's the only term over there. I'm going to get negative 35 equals what? X. You're done. So it ends quick. It ends quick. And there you go. Okay. So you have your 30 problems to study. You have everything you need. don't forget to come take this final. I will track you down. I'm going to repeat 1 through 13 tomorrow. If you'd like to come in and hear it, you certainly can. You are all welcome.
Same hours.
Same hour, third hour. I'm going to be in here doing 1 through 13. So you're welcome to come in.